It's not just rolling. It's striking the ground again and again. Inside that drum, a hidden force beats over 3,000 times per minute. And that's the real reason roads don't fall apart. So what exactly is happening inside that steel drum? Let's break it down. On construction sites around the world, road rollers move steadily over freshly laid asphalt, appearing calm and uneventful. There's no dramatic speed or aggressive motion, just a steady roll forward. But inside, something far more intense is happening. Beneath that quiet exterior lies a system generating rapid vibrations and repeated mechanical force, delivering energy into the ground thousands of times every minute. Engineers often describe this as the machine's heartbeat, a rhythmic pulse that transforms loose material into a solid, durable surface. What looks simple on the outside is actually performing one of the most important operations in modern infrastructure. At first glance, the road roller seems incredibly basic. It has a heavy steel drum in the front, large rubber tires at the back, a diesel engine, and an operator guiding it forward. Because of this, most people assume its effectiveness comes purely from its weight. The logic feels straightforward. More weight should mean stronger compaction, but that assumption is only partially true. If weight alone were enough, construction crews could simply drive heavy trucks over fresh asphalt repeatedly. Instead, they rely on road rollers because these machines apply something far more powerful than static weight. They introduce vibration, and that is what truly transforms the road. When asphalt is first laid, it isn't a solid surface yet. It's a carefully prepared mixture of crushed stone, sand, and bitumen, which acts as a binding agent. At this stage, the material contains countless tiny air pockets trapped between particles. These air gaps might seem insignificant, but they are actually a major weakness. If they remain, water can seep in, temperature changes can cause expansion and cracking, and constant traffic pressure can slowly deform the surface. Over time, these small weaknesses turn into visible damage. Proper compaction removes those air gaps, forcing particles closer together and creating a strong, durable structure. And that's exactly where the roller's hidden mechanism comes into play. The front drum of a road roller may look like a simple steel cylinder, but inside it lies the core of the machine's power. A rotating shaft runs through the drum, fitted with an eccentric weight, meaning the mass is deliberately positioned off-center. As this shaft spins, the imbalance creates a powerful oscillating force. It's similar to swinging a heavy object tied to a rope in a circular motion. You can feel the pull increasing and shifting with every rotation. Inside the roller, this effect is amplified and controlled, happening dozens of times every second. The result is a rapidly vibrating drum that transfers this energy directly into the ground beneath it. This vibration system produces what engineers call dynamic compaction force. Instead of simply pressing down with weight, the drum repeatedly delivers rapid pulses into the surface. Each vibration acts like a tiny hammer strike, but these impacts occur at an incredible frequency, typically 30 to 50 times per second, adding up to more than 3,000 vibrations every minute. This continuous rhythmic force is why engineers refer to it as the machine's heartbeat. It's not random or chaotic, it's precisely controlled, delivering consistent energy into the asphalt to reshape its internal structure. These rapid vibrations cause the particles within the asphalt to shift, settle, and lock together more tightly. Imagine shaking a container filled with sand and small stones. Everything gradually settles into a denser arrangement as gaps disappear. The road roller performs the same action, but with immense force and precision. As the particles rearrange, air pockets collapse, and the material becomes more compact. This process creates a surface strong enough to withstand heavy traffic, extreme weather conditions, and long-term wear. Without this vibratory compaction, even the highest quality asphalt would fail much sooner than expected. Modern road rollers are designed to adapt to different stages of construction, which is why they operate in two main modes. In static mode, the drum relies only on its weight, making it suitable for finishing touches or delicate surfaces where excessive vibration could cause damage. In vibratory mode, the internal shaft spins and generates powerful oscillations, making it ideal for the main compaction phase when the asphalt is still hot and flexible. By switching between these modes, operators can carefully control the compaction process, ensuring the road achieves the perfect balance between strength and smoothness. Compaction isn't just about force, it's also about timing. Fresh asphalt is laid at extremely high temperatures, typically between 150 and 170 degrees Celsius. At this stage, the material is soft enough for particles to move and settle into tighter configurations, but as it cools, it quickly becomes rigid. Once that happens, vibration becomes far less effective. This is why road rollers operate closely behind paving machines, working within a precise time window. If compaction is delayed, the asphalt may never reach its optimal density, compromising the strength and longevity of the road. Although road rollers appear rugged and straightforward, the engineering behind them is highly precise. The vibration system must be perfectly balanced to ensure efficiency and prevent damage to the machine itself. Engineers carefully calculate several key factors, including vibration frequency, amplitude, drum weight, and engine power. Each of these elements plays a crucial role in determining how energy is transferred into the ground. Too little vibration would leave the material loose, while too much could damage the asphalt or underlying layers. Achieving the perfect balance is what makes the machine so effective. Different construction tasks require different types of rollers. Single drum rollers with one steel drum and rear tires are commonly used for heavy compaction. Double drum rollers feature two steel drums, both capable of vibrating, and are often used for finishing surfaces smoothly. Pneumatic rollers, which use multiple rubber tires instead of steel drums, apply more uniform pressure and are ideal for specific compaction needs. Each type serves a unique purpose, working together to ensure that roads are built to withstand years of use. If compaction is not done correctly, the consequences appear quickly. Roads may develop cracks, form ruts under vehicle pressure, or break apart into potholes. Water can seep into weak layers, accelerating the damage even further. In some cases, these problems can emerge within just a few months. This is why compaction is one of the most critical steps in road construction. The vibrations generated by the roller ensure that each layer, from the foundation to the surface, is tightly packed and structurally sound. What makes the road roller so fascinating is how it uses simple physical principles in a powerful way. It converts rotational motion into oscillating force through an off-center weight, then transfers that energy into the ground to reorganize millions of particles beneath the surface. All of this happens while the machine moves slowly forward, appearing calm and controlled. From the outside, it may seem like a basic piece of equipment, but inside, it's a finely tuned system shaping the infrastructure we rely on every day. The next time you see a road roller moving across a construction site, you'll know there's more happening than meets the eye. That steel drum isn't just rolling, it's vibrating thousands of times every minute, sending waves of energy deep into the ground. With every pulse, it strengthens the road beneath your wheels. What once seemed like a slow and simple machine reveals itself as one of the most important tools in modern construction. A road roller may look simple, but inside it's a precisely engineered system driven by a powerful mechanical heartbeat. Thousands of controlled vibrations every minute compress loose asphalt, remove hidden air gaps, and transform it into a surface strong enough to handle years of pressure and traffic. What seems slow and ordinary is actually shaping the foundation of the roads we rely on every day, and once you understand that, you'll never look at this machine the same way again. So next time you see a road roller, tell me in the comments, did you ever imagine this was happening inside? And if you enjoy discovering the hidden science behind everyday machines, make sure to subscribe, because there's a lot more you haven't seen yet.